yesterday we were doing the properties due to the cleavage of oxygen-hydrogen bond or acidic properties of alcohol. Okay, so there we have done a few reactions. All right, and we have also done the formation of the reaction of the carboxylic acid, the formation of esters. Okay, so there I want to include one more, the reaction of alcohols with acid chlorides and acid anhydrides. Okay, reaction of alcohols with acid chlorides. Can you see?
না স্যার কেটে যাচ্ছে স্যার।
Okay, now you will be able to see reaction of alcohols with acid chlorides and acid anhydride. Okay. Now first I do with acid chlorides. Acid chloride. Now what is an acid chloride? Acid chloride is a derivative of carboxylic acid. Okay, this is called acid chloride. Acid chloride. Okay, now when I add their alcohol, see here what happens. R1 and this is R2. Clear? Now see what happened. Now it will undergo substitution. So here from here the H will go. Because of that we call it the acidic property of alcohol, because here alcohol loses H plus and acid chloride loses Cl minus. So this reaction will give you what? So let me join it here. R1 R2 plus HCl. See, this reaction is producing pure hydrogen chloride as byproduct. So in that case, the rate of the reaction will be slow. So what should you do? We should remove the acid from the reaction. See, to remove water from our body, we use a towel. If you have a running nose, you use hanky, because it absorbs it. So if I have to remove acid from the reaction, then I have to use a base. So here we are not using any inorganic bases like sodium hydroxide, potassium hydroxide, calcium oxide. Here we are going to use an organic base, and that base is called pyridine. Pyridine. How does pyridine looks like? Pyridine is almost like benzene ring, but within the ring we have one nitrogen. So this is the lone pair which reacts to the cell and remove it from there. Okay, let me write it for you. I told you no. Nobody should tell my students are ignorant. Whatever I have learned in my life, I am going to teach. And it is up to you only whether you can remember or not. See, this hydrogen will come here. So what you are going to get? You will get, see, now nitrogen has become positive, because valence has become 4, and this is the 1. So if this is pyridine, like NH3 reacts with HCl to give you ammonium chloride, so this one is called pyridinium chloride. Pyridinium. Please remember, pyridine is frequently used in organic reactions as a base to remove acids. Because of that, we call them as acid scavenger. Okay, So what is this? This is also, oh, sorry. So this is an ester. So as we can prepare ester from carboxylic acids, we can also prepare ester from acid chlorides. And these reactions are irreversible and very, very fast in nature. Okay, so I'll give you now specific example. Okay, see, I have taken here CH3CO Cl. This is called acetyl chloride. This is a common name. And what is the IUPAC name? Is called ethanol chloride. Clear? So now to that you have added ethanol. Then what you have to do? You have to use here pyridine. Okay, what is going to happen? This will go out, and here you will get CH3, CO, O, CH2, CH3 plus HCl. So this is an ester. What is the name of this one? This is called ethyl acetate. Okay, and what is the IUPAC name? IUPAC name is ethyl ethanoate. Clear? So this we have done with aliphatic acid chloride. So now let me write an aromatic acid chloride. Okay. So if I write aromatic acid chloride, so let me get. So let me write it like this. This. Okay. This is called benzoyl chloride. It's a common name. Okay. I'm not going to write the IUPAC name because IUPAC name of this compound will not be able to remember. But anyway, I'm just telling you, it is called benzene carbomoyl chloride. Okay, I'll write it for you. Benzene carbomoyl chloride. Okay, so what you are going to get? You'll get here pyridine. Okay, you'll get here CH3, CO, O, CH2, CH3 plus HCl. So this is called ethyl benzoate. Okay, and its IUPAC name is ethyl benzene carboxylate. All right, so this is also the property due to hydrogen of an alcohol. Okay, now we'll go for acid anhydride. Okay, so now what is acid anhydride? That also I've shown you that acid anhydride is being prepared from corresponding acids only. We take carboxylic acids, whether it is aliphatic or aromatic, and we heat it more than that 100 degrees Celsius. All right, and we add some reagent to absorb water. All right, now see here. This is known as an anhydride of acetic acid. So its name is acetate anhydride, and its common name, IUPAC name is ethanoic anhydride. Now, if I react it with alcohol, and here also you can use here pyridine. In that case, what is going to happen? See here. This will go out. So if H joins here, you will get acetic acid and this will go here. So what you are going to get here? CH3, CO, O, CH2, CH3. You will get here ethyl acetate. And I'm going to write, do not get confused. See, this. Then I'll write this. Then this H will come here. So what do you get? In acid chloride, you got HCl. Here you are going to get carboxylic acid. So what is this name of this one? It is called acetic acid. So with this, I finish few properties of acidic properties of alcohol. All right. So now I'll go to the second category of reaction, because that you have written down what are the different types of properties can be shown by alcohol. First is the properties due to the cleavage of oxygen hydrogen bond or acidic properties of alcohol. So under this heading, what did you find? We find alcohols are weak acids, very, very weak acids, but under given condition and also the highly reactive reagents, alcohol can act as an acid. So when alcohols you react with very strong electropositive metals like group 1 metals, group 2 metals, aluminium. So in that case you find they react with sodium, potassium, lithium. They react with calcium, magnesium. They react with aluminium to form corresponding salts. Okay, we call them as metal alkoxides along with the liberation of hydrogen. Yeah. Now we have found that acidity of alcohols vary from alcohol to alcohol. Okay, and alkoxides are not stable because the alkyl groups are electron donating, so they have a severe repulsion within the alkyl group and the oxygen carrying negative charges. Okay, so in that case you find that acidity of alcohol decreases with increase in alkyl group. So among the alcohol series, the strongest acid is primary alcohol, followed by secondary alcohol, and then the tertiary alcohol. So then I also, yes.
So can you explain that reaction again? That reaction? So can you explain that reaction again?
Which reaction, dear? This one?
That one, sir. Yes, sir. Yes, sir, that one.
See here. Earlier, okay. Now you just forget about this. Lower part you forget. This one you understood? H and Cl went and oxygen got bonded here. This so you could understand?
Yes, sir. Yes, sir.
Now I'm replacing this by oxygen. What is going to happen now? Here, this hydrogen will combine with this. Why will you combine? See there. Because this plus will come and combine with the lone pair. Okay, then this bond will break because oxygen cannot have more than oxygen cannot expand its valency beyond 2. So this will break, then this O minus will. Shankar?
Okay, yes, sir.
Very good. I'm so happy that at least someone could ask me a question. Otherwise, I'm thinking that you are sleeping on the bed and watching this. Okay? Okay. Now, we have found that the anion of the alcohol are strong bases. Okay? So, as you find, the acidity decreases from primary, secondary, and tertiary. Basicity, basicity, the order is reversed. Tertiary alkoxides are strongest base because of the presence of 3 alkyl group, followed by secondary, then primary, and the last one is methoxide. Now we have come to the reactions. Okay, so we have discussed about the reaction of alcohol with metals. Then we have discussed the reaction of alcohols with carboxylic acids, reaction with acid chlorides, reaction of alcohols with anhydrides, and also one more reaction which I have done is not given in the book, the reaction of alcohols with Grignard reagents. Now I'll go to the second category of reaction, that reactions due to the cleavage of carbon-oxygen bond. Our second category reaction. Okay. B. It is properties due to the cleavage of carbon-oxygen bond or nucleophilic substitution of which group? Now, why do you call it nucleophilic substitution reaction? See here, I have taken an alcohol. Okay. Now I'm going to break this bond. When I break this bond is polar because of the presence of electronegative oxygen atom. So the molecule exists in this form. So it will undergo heterolytic cleavage. And this will go out in the form of OH minus. And this will become plus. So this place has to be taken by another electron-rich species in order to satisfy the tetravalency of carbon. So electron-rich species are called nucleophile. So one negatively charged species is replacing the hydroxide. Clear? Due to that, we call it nucleophilic substitution reaction. Okay. So under this heading, first thing that we are going to study is the reaction with hydrogen halides. Hydrogen halides. That is RCH2OH HX. So this X minus is going to replace OH minus. Okay. See, in the chapter of Hello Alkane, we have done all this reaction. But I told you, it is a natural phenomenon. The strong always replaces weak. But if you compare the nucleophilicity of hydroxide, which is going out, and compare with the incoming group X minus, we find hydroxide is stronger than halide. Then how it is possible that a weaker one is being replaced by the stronger one? Yes, it is possible. If weaker one takes the help of another person, then the strength become more, and he can replace a stronger one. Okay, suppose say you are being harassed by someone whom you are scared, then you take the help of some other persons. When both of you go together, then your strength is increased. So here also, first you try to understand the mechanism. Once you understand the mechanism, then after the organic chemistry is nothing. With your left hand also you can write. Okay? Now see here. See, I'm not ignoring left hand. See here. How does it take place? So let us try to understand the reaction. Once you understand the reaction, then things become very easy. See. Step 1. HX. Acids will they are all strong acids. So it will immediately undergo dissociation. Okay. Step 2. we know that any species having lone pair, it can donate this pair of electron to electron deficient species. So alcohol is a Lewis acid and is a strong Lewis acid. Why? Because it has an electron donating group along associated with it. All right. So now this H plus, see, it will immediately donate this pair of electron. So what you are going to get here, you will get here RCH2 OH. Look at this. This type of species, where oxygen attains trivalency, we call them as oxonium ion. Oxonium. I'm not writing the mechanism, it's called oxonium ion. Now, this trivalency of oxygen is not stable. So what it will happen? Oxygen again like to go back to its divalent state. So what is going to happen now? See here. R CH H this like this. Then what you will get? You will get here R C H plus this. See, just by taking the help of the hydrogen ion, we could break the carbon oxygen bond. All right. So you have got a carbocation. Clear? Now the carbon from valency 4, it has come down to valency of 3. So now it will immediately let you go back to its tetravalency. So step 3. Step 3. So in that case, we'll find R CH this plus X minus. Okay? It will give you, and what you are going to get here? R CH X. Clear? So this is the whole mechanism of formation of haloalkanes. So see, though you are going to get this video, but my request, please write down this mechanism. Please write down. Once you write by your hand, 50% will go to your memory. Please write. Oh. Have you finished? Hello?
Yes,
Very good. Now see here. This carbon contains how many hydrogen, dear? 2 hydrogen.
two.
Is it not a primary carbocation? Huh? So
Yes, sir.
write down the statement. Right. Right. Formation of haloalkanes. By the reaction of alcohols and hydrogen halides. Goes through carbocation intermediates. Full stop. Right. So more stable the carbocation is, faster will be the rate of reaction. All right. So, right below now, next paragraph. Thus, the rate of the reaction depends upon the nature of alcohols and HX. Okay, now see here, I'll write 1. It is for HX, I'll write here now. HI, HBr, and HCl. I'm not bringing HF. HF does not follow this one. See here, among this, because this reaction is initiated by H plus, so whichever acid undergoes very fast dissociation, that reaction will be faster. HI undergoes very fast reaction because it is the most acidic, followed by HBr and HCl. And second, alcohol. Okay, then you write here tertiary. Okay, I'll give you the molecule, then it becomes easy for you. Okay, this. Why, dear? If it goes out, what do you get? Do you not get tertiary carbocation? It is the most stable. Okay. Then followed by secondary, then followed by primary. Okay, primary. Next molecule I'm going to write, that is also primary, but it will not have any alkyl group. This is what? This is methanol. See why? If you understand the reaction, then you can do it by yourself. See here, when it becomes positive charge, there are 3 methyl group supplies electron. It makes it more stable. So the formation immediately takes place. I'll show you the reaction now. This one, 2 alkyl groups are pumping electrons. Okay. So this is also stable, but it is less than there. Here you have only 1 alkyl group. Okay. And this does not have any electron donating alkyl group. All right. So this is the rate of reaction. This is also primary alcohol, but it does not have any electron donating alkyl group. Right. Then after that, your background is very weak. I cannot go fast, and I need not go fast also. Whatever I will do, we'll do it nicely. See, entire organic, I have started writing it, but you will not have that much patience to read because it runs to 60, 70, 80 pages. So you'll get bored. Because of that, I'm writing again summary for you people. I have finished writing haloalkanes. I have finished writing alcohol phenol ethers. I have finished writing aldehydes, ketones, carboxylic acids. Yesterday night I have finished, and now I'll write the summary of aldehydes, ketones, and then I'll request Somnath you'll make a PDF file and just send it to you maybe after 1 week. But I cannot write so fast. Finish writing?
Yes,
Hello?
sir.
Now we'll go
Yes,
for
sir.
individual reaction. So we'll go for reaction of alcohols with HCl because it's important for exam. So I'll write now here reaction of alcohols with HCl. All right. See here. So I'm writing here. I write a specific reaction. So I'm taking tertiary butyl alcohol. Now you know the mechanism. What is going to happen? This will go out and you will get tertiary butyl cation, which is a tertiary carbocation. And tertiary carbon is very, very stable. So now here I'm going to use here hydrochloric acid, and that is concentrated. Okay. So what it will give us? It will give us tertiary butyl chloride and water. See, this is a reversible reaction. Why? Weak is replacing strong. So whenever the strong will get a chance, it will again like to come back. It's just like a wrestling. So what you have to do, if you wish that this should stay in the reaction, you should remove this water molecule from here. How to remove water molecule? Now you know the technique. For that, you have to use a substance which will absorb water as soon as it comes out. So these are called dehydrating agent. So we are going to use a dehydrating agent. Okay, so I'm going to use here anhydrous zinc chloride. Anhydrous zinc chloride absorb, each molecule absorbs 6 molecules of water. All right. So in that case, we use this one. See, this is colorless. This is also colorless. In the test tube, when you add 2 colorless, when you mix 2 colorless solution, that also will be colorless. But moment you add there, you will find that the test tube solution has become cloudy. Initially, it was transparent. It has become opaque or translucent. We call it turbidity. Okay. So what I am going to write? We'll write here immediate turbidity. And this reaction we have done at room temperature. Okay, so now we go for a secondary alcohol. Okay, this is called commonly known as isopropyl alcohol. This is a secondary alcohol. Okay, so similarly I have added here concentrated HCl and I have added here anhydrous zinc chloride. Then what it is supposed to form? It is supposed to form this. But as we know, the secondary alcohols are little less stable than that of the tertiary, so it takes little time. So you will find turbidity is going to appear. You go on shaking it. After that, after 5 minutes, the turbidity appears. So we'll write here turbidity appears after 5 minutes. Okay. Oh, I made a mistake. It should be CH3. Huh? Please don't mind. CH3. Then I'm taking primary alcohol. This one, you know it very well. This is called ethanol. Okay. Ethanol. Okay. This is primary alcohol. So to that I have added concentrated HCl at room temperature. At room temperature, and here also I use here anhydrous zinc chloride. Here, this reaction does not occur at room temperature. The solution will remain clear, transparent. So we'll write here, no product forms at room temperature. But see, it does not mean reaction does not go. It goes when you heat it. Okay? When you heat it, the turbidity will appear, otherwise is not going to appear. Clear? See, this reaction is being used for distinction of alcohols. It's very important for exam. Okay? So if you are being given 3 samples of alcohol and ask you that please find out which is primary, which is secondary, and which is tertiary, no problem. We'll take 3 test tubes, and in the 3 test tubes, we'll put alcohol. Then in the test tube, we'll put anhydrous zinc chloride. Now, with the help of dropper, in all these test tubes, we are going to put concentrated HCl in all the 3 test tubes. The test tube in which immediate turbidity is appearing, cloudiness has appeared, you will say it is tertiary. The other 2 test tubes, you go on shaking, you will find in the second test tube, the turbidity is appeared after 5 minutes, then it is secondary. Obviously, when you identify out of 3, 2, then you know the last one is nothing but primary alcohol. But this test tube, you warm it for some time over burner, you'll find the turbidity has appeared. Okay? So this process of distinction of alcohol is known as Lucas. L-U-C-A-S. Lucas, not look us. Lucas test. It is called Lucas test. All right? And concentrated HCl and anhydrous zinc chloride. This is the reagent. Okay? So this is called Lucas reagent. Don't forget. Okay, concentrated HCl and zinc chloride is called Lucas reagent. Often this question comes in the exam. They will give you how can you distinguish between tertiary butyl and ethanol. You will simply have to write only one line by Lucas reagent. Tertiary butyl produces immediate turbidity, whereas ethanol does not produce any turbidity at, you have to write down, at room temperature. If they ask you to distinguish between secondary alcohol and primary alcohol, you write that secondary alcohol produces a turbidity after 5 minutes, whereas primary alcohol does not. Clear? Okay, so we have done this reaction of HCl with the alcohols. Now we'll go for HBr. One line I'll do it because I have already discussed this one in the preparation of haloalkane. See, this is the advantage of organic. The reaction of a compound is the preparation of others, so you don't have to read it twice. Be little intelligent. Now, reaction with HBr. So I'll write like here RCH2OH and HBr. Here we are not using anhydrous zinc chloride as dehydrating agent. Here we are going to use concentrated H2SO4. So here we are going to get RCH2Br plus H2O. Reaction with hydrogen iodide. In that case, these are all concentrated. Hydrogen iodide. Here we do not use, I already told you in haloalkanes that we cannot use concentrated H2SO4 because concentrated H2SO4 oxidizes hydrogen iodide to iodine. Okay, so I'm not going to repeat it because in haloalkane video you will find it given there. So here we are going to use H3PO4. Is a very strong dehydrating agent, but it cannot oxidize. So you will get here now RCH2I plus H2O. So with this, I finish the reaction of alcohols with hydrogen halides. Okay? Now, the second category of reaction.
Oh, wait.
Hello?
So wait, I'll copy.
No, this one you will get from it is there in the book also, and video also will get it. Where mechanisms are there, because until unless you don't have mechanism, you don't understand here. Okay? Okay, now. Second reaction is reaction with thionyl chloride. Reaction with thionyl chloride. What is the formula of thionyl chloride? SOCl2. Okay. So if you have taken thionyl chloride is a very active reagent. So if you have reacted with, I'll show you how to remember. Okay, first I'll write it like this. SOCl2. It will immediately form chloroalkane. Then you'll get here sulfur dioxide gas, and you will get here HCl. You can see literally that these white fumes are coming out from there. Now, how to remember? Okay, very easy. See here. R, CH2O, and H. Then you write like this. Okay? Write like this. And You write it like this. Now you cut it like this. See, RCH2Cl, 2 oxygen, sulfur dioxide, and HCl. This is the way to remember. So any alcohol gives, suppose you forget, you write it like this. Immediately the product comes. See here, product one, first product, second product, third product. Clear? So suppose you have taken CH3, CH2, CH2, OH. All the time they will not give you ethanol. Okay? If it is a reaction of thionyl chloride, what you write? S, Cl, Cl, O. Right. So what you get here? You get here now sorry. It is CH3, CH2, CH2, Cl plus SO2 plus HCl. See, automatically the product comes. Okay? Be little intelligent. Sufficient to get full marks in organic. See, even a fool like me also could teach you organic. Then why you people are so intelligent? Such wonderful result you have. We do not have that much result. Okay. Now, we'll write here reaction with phosphorus pentachloride. Phosphorus pentachloride. Okay. So now I'll write it here. RCH2OH PCl5. It will give you RCH2Cl POCl3. Okay. I'll write down the name of this one. Name is phosphorus oxychloride. Phosphorus oxychloride. Plus you'll get here HCl. Then I'll show you how to remember the technique. See here. RCH2OH. Right. P Cl 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 Cl. Now you break it like this. See, RCH2Cl, POCl3, and HCl. All right. So now we'll write here reaction with phosphorus trihalides. Okay. I'll write here PX3, where X can be chlorine, bromine, or iodine. So in this case, it is little different. You'll find RCH2OH. See, in case of thionyl chloride, 1 molecule of alcohol reacts with 1 molecule of thionyl chloride. With PCl5, 1 molecule of alcohol reacts with 1 molecule of PCl5. And in case of the phosphorus trihalide, 3 molecules of react with 1 molecule of trihalide. What does it give? It gives you RCH2X3 and H3PO3. H3PO3 is called phosphorus acid. The H3PO4 is called phosphoric and H3PO3 is called phosphorus. We know in chemistry, higher one is called ic and the lower one is called us. So it is phosphorus acid. All right. So let me write it here. Say you have taken ethanol and you have reacted with PCl3. What you will get? CH3, CH2Cl, 3 molecules, and you get here H3PO3. Now, if you have reacted, if you have taken here phosphorus tribromide, then you can get here CH3, CH2, Br, and H3PO3. Now, see, phosphorus trichloride is easily available and cheaper. But phosphorus tribromide, see, in this world, if you pay money, you can get it. But it is costly. So what I'll do, I'll make it in the lab. I'll take red phosphorus. Red phosphorus. When I'll go to P block, I'll tell you red phosphorus. And I'll take red phosphorus, you have seen. See, the side of the matchbox and matchstick contains red phosphorus. White phosphorus is extremely reactive. The moment you take out from the bottle, it catches fire. So, this white phosphorus, we heat it in closed chamber for a few days, then it becomes red phosphorus. These are called allotropes. All right, I'll take red phosphorus and I'll take here bromine. Okay, so you'll find if I take here 2 and if I take 3, immediately in the flask, you are going to get here PBr3. So in exam, they may not, just to confuse you, they may not give you PBr3. The same reaction they will give you in this way. CH3, CH2, OH, and they'll put an arrow and write here P and Br. Okay, they may write here red phosphorus. So if you write this, don't faint. Don't say Annilayap. Okay, this is nothing but PBr3. This is the way to confuse you in the exam. Okay, so what will do? You will write directly the product. You will write here CH3, CH2, Br plus H3PO. Like that, you will get full marks. Okay. Now, if I have taken phosphorus tribromide, triiodide, so what I'll get it here? I'll get here PI3. Okay, PI3. So this is, I will get here ethyl iodide and phosphoric acid. Now, how can you generate? See here, you write 2. Here below you write 2 red phosphorus and you write here 3I2. So it will give you 2PI3. All right. Okay, let me see. I have to be very selective, otherwise the gun case. Okay. So now we will go for the third category of reaction, where you find the hydrogen from the alcohol and the OH group from the alcohol goes out and it gives us an alkene. It is the C. You will find a copy of it already you have written. C is what? Properties due to the simultaneous cleavage of beta carbon hydrogen and carbon oxygen bond, or we call it elimination reaction, or we call it dehydration reaction. Clear? So we go for beta elimination reactions or dehydration of alcohols. Okay, so how it will happen? See, it will happen like this: C H H C O H H. Okay, so to that we will add concentrated H2SO4. Okay, and we'll heat it at 443 Kelvin. This temperature you don't forget. Very important. So what is going to happen? The molecule of water will go out. So what you will get here? RCH, H, H, and H2O. So it gives us alkene. It gives us alkene. So this mechanism to understand. So this is the one. Now you will write mechanism. See here, mechanism. You know what did you add? Acid. So it is immediately will undergo dissociation. Is a strong acid. So what you will get here? H plus, and you can use HSO4. So this reaction can be carried out in presence of concentrated phosphoric acid. Okay, or you can use here hydrogen chloride gas. Or generally we do not, because it's very difficult to handle hydrogen chloride gas. Okay, it's not harmful, it is harmful for us also. So we use either concentrated H2SO4 or concentrated H2SO4. Okay, either we use phosphoric acid or sulfuric acid. So what you will get now? See this. Step 2. Step 2. So what is going to happen? I have already shown you that alcohol are strongly used. What? Acids. So the bases H plus. So immediately it will go like this. So what you are going to get? You'll get here R, C, H, H, C, H, 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 and H. Look there. This is not oxygen ion. So this carbon oxygen bond will break. Will go out. So what you are going to get? You will get here R, C, H, C, oh sorry, H, H plus H2O. See, you've got a carbocation. What type of carbocation is it? It is primary. Because I've taken a primary alcohol. Okay, this is a primary alcohol. Okay, primary alcohol. I'll write now here. Primary alcohol. Then step 3. See, these are reaction intermediates. Reaction intermediates are not stable. So what is going to happen now? Okay, so R, C, H, 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 H. Clear? Now see, this carbon hydrogen bond has how many electrons? 2 electrons. One electron is here and other electron is here. But this carbon wants electron. What it will do? So this hydrogen is going to sacrifice this electron. Okay, it will go. This bond will break. Okay. So what you will get now here? You will get here R, C, H, C, H, and you will get here now H plus. So again, I am explaining mechanism. When you add concentrated sulfuric acid or phosphoric acid to alcohol, and if you heat it at 443 Kelvin, in that case, what will happen? Mechanism, first acid will give you H plus ion. Clear? Now, H plus ion. Now, as the alcohols are loose bases, it will immediately react to the acid to form an oxonium ion. Then after that, the carbon oxygen bond will break and it will give you corresponding carbocation. Then this hydrogen from the beta carbon. See, this was alpha, this is beta. So carbon hydrogen beta carbon hydrogen bond breaks, leading to the formation of alkane. So this is the mechanism. Please write this one. Please write. See, once you finish, you tell me, huh? Hello, finish.
Yes, sir.
Acha. Now you write. Right. Dehydration of alcohols to form alkenes goes through carbocation carbocation intermediates. So, hence, more stable the carbocation is, faster will be the process of dehydration and formation of corresponding alkenes. Then write below. Rate of formation of alkenes is, put a colon, right, tertiary alcohols, secondary alcohols. Then you write primary alcohols. Okay, so we'll write. See here. This is primary alcohol. So here we'll take concentrated H2SO4 or concentrated H3PO4. See, concentrated H2SO4 is 98%. Concentrated phosphoric acid is 100%. Temperature is 443 Kelvin. All right. So what is going to happen now? H and OH will go. So you get now here. Sorry. You get here ethene plus H2O. Now when I go for secondary, say I have taken here CH3, C, OH, H, CH, H, NOH. This is ethanol, this is propan-2-ol or isopropyl alcohol. Okay, alcohol. Secondary. So here, as because this carbohydrate is more stable than this, so I don't have to put so much of pressure on it. I need not exert it. So what I take here, 70 to 80%. 80% H3PO4 or H2SO4. Temperature is same, 443 Kelvin, but this one I have diluted. So what I will get? This will go out. Okay, this will go out and you will get here CH3, CH, plus H2O. Now when I take tertiary, see here, I take here OH. This one I'm going to write like this so that it becomes easier for you to understand what goes out, and CH3. This is tertiary alcohol. Okay. Here I'm going to take 20% H3PO4 or H2SO4. In your book, conditions are not given. Forget. Temperature 3 Kelvin. Okay. This is 3, and this water has gone, so this carbon has 2 hydrogen. So don't break your this up. SAR is not magic only. See here. All right. This is tertiary. Okay. So this one you need not write it. In the book also, as well as in the video. Okay. Direct video cannot be sent because 1 hour class, so much of direct video cannot be sent because it will not go to the mobile memory. Okay. So you know life is not so ideal, and in exam also they may not be good. Okay. Mind it is a beta element. Yeah. So let me take a situation here like CH3, CH, C, OH, H, CH, C. Okay. So what is this? This is isobutanol or butan-2-ol. Right now. Butan-2-ol. Okay. Or it may be called as isobutanol. Emboss, they will give you this. Okay. CBC, they may give you this. name, isobutanol. I told you what is one is iso when OH group is on the second carbon. See, because you have to count from this side 1, 2, 3, 4. If you count from this side 1, 2, 3, so this is wrong. So this is second carbon OH is there. Moment OH is there, second carbon, just you put one iso. Then count the number of carbon. How many are there? 4. Isobutanol. All right. Now see, this is alpha carbon. This is beta. This is also beta. From both sides, the hydrogen will go. So you are going to get 2 alcohols. Okay. Here, concentrated H2SO4, 443 calories. Okay. So in that case, you are going to get here 2. Suppose H and OH goes out. Okay. So you will have bond between second and third carbon. So you don't have to worry. See, this is first carbon, this is second. I'll put a double bond here. All right. So this is this one is this is this. Then you have CH. All right. Second, hydrogen can go from here. Okay. So go from this between first and second. So I'll write like this. CH. I write from right hand side. See. So this has gone out. This is this one. This is this one. Now this hydrogen is still there. So right here. This. Now what is this? CH2 CH3 is what? Ethyl group. So right here now. CH2 CH3. So you will get here 2 alkenes. I told you that this follows Safe-Jeff rule. See, this alkene is more substituted. Why? Because it is having less hydrogen on the vinyl carbon. This is having 2 and this is having 3. So this is less substituted and this is more substituted. Okay? In that case, according to Safe-Jeff rule, this is going to form more in amount. Okay? So what is the name of this? I'll write here now. 1, 2. So it is bute 2 E. And this will be major. And this is, see here, you have double bond between first and second carbon. So it is bute 1 E. Bute 1 E. So this is major and this is minor. Clear? So let me stop here. So tomorrow we'll continue because I need not go in a hurry. All right? Huh? Okay, wish you a good day. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Then, my manager is there. He is present. Huh? Miss Drishti Rao. What happened? Drishti is there or not? Then Aditi from the army school or having classes? Okay. Eugenia is there.
Yes, sir.
And that Mr. Slow is there.
Sir, I don't know.
Acha. Daniel is there. Daniel?
Yes, sir.
Acha.
sir.
Then Lawan?
Yes, sir. Here.
Okay, bye then. Good day.
Bye, sir. You too.
Bye, sir. Bye, sir.
Bye, sir.